All right, here's the second practice problem explanation on oxidation number practice and then using oxidation numbers to write formulas. Again, for that physical science lesson for April 20th to 24th. So remember the slide from the video notes where it talked about a +1 or a -1 on top of the periodic table. We were discussing whether or not it was easy to lose or gain electrons. So you're just going to want to think about atoms getting to 8 valence electrons. So to fill this chart out, its oxidation number is identifying if it's easier for an atom to gain or lose electrons and how many in order for it to get to 8. And so for example, hydrogen would have an oxidation number of 1 because it's easier for it to lose 1 electron than gain 7 electrons. Also, a trick that you can start recognizing is that it's in column 1. So if something is in column 1, its oxidation number will be a +1. We'll jump down and do chlorine as an example as well. Chlorine's oxidation number is -1. It's a halogen, and so it's easier for it to gain 1 electron than lose 7 electrons. Go ahead and fill in the others here as examples, and then you can check the key that's linked to what you're doing. So using these oxidation numbers, why do we have oxidation numbers? It's to help us identify and be able to write formulas for compounds, and mostly we're going to use these to write formulas for ionic compounds. So we're going to follow these steps here. My first example is going to follow these steps and then fill in with the Li and the F here going together. So the first thing that you're going to do is find the oxidation number for each element using the plus or the minus. So figure out where lithium is on the periodic table, and we see that lithium is in column 1 on the periodic table, so it's a +1. Then you're going to see that fluorine is in column 17 on the periodic table, or it's a halogen, and so its oxidation number is a -1. So over here, what we want you to do is put your +1 and your -1 as superscripts above those elements. Okay, so you're then going to take those oxidation numbers and cross them over and place them as subscripts. So a way that I like to remember this is your charges are light, or your oxidation numbers are light, and then your numbers are heavy. So as soon as you cross them, you want to then drop the charges. So in this case here, you have Li1 and then F1. So notice that there's no charges down here. So your subscripts should never have a charge with it. But when you're identifying your oxidation numbers, they will have a charge because that's helping you identify how many elements you need in the compound in order for it to be happy or have those 8 valence electrons. So then you're going to rewrite the formula for the compound neatly, which will look like this. In this case, though, this is going to follow one of the rules. So any element with the subscript of 1, you're going to drop that subscript. And so you're going to say just LiF, and we would name this lithium fluoride. So you don't write the 1 if there's a 1 there, but I do still want to have you practice this part with the crossing over for those oxidation numbers. If both subscripts are the same, you do not write them. All right, let's jump down to another example. Oh, one thing, please note, all cations or metals are written first in your chemical formulas, and then all anions or nonmetals are going to be written second. So the order here matters, so please keep it in that order. So then we're going to do the K and the S as practice as well. So find where potassium is on the periodic table, and you see that potassium is in column 1, so it's a +1, and then sulfur is a -2, where it's at on the periodic table. So you've put your oxidation numbers in, and then what you're going to do is cross them over. So you'll notice you're crossing to the lower right-hand side and where you would put a subscript. Then what you're going to do is rewrite it, and so you've got your K2S1, and remember from your rules up above that you would drop the 1, and so what this would look like would be a K2S, and we would say potassium sulfide in this situation. All right, good luck with the rest of these. The key is also linked to your practice problems with what you're doing. Good luck, and thanks for listening.